Welcome to the Slumber Lab. I'm so glad you found your way here tonight. Whether you're already tucked beneath your covers, settling into your favorite chair, or simply letting the day's tension melt from your shoulders, this space was created for you. Tonight, we're embarking on a journey into one of physics' most tantalizing mysteries. Something that exists only in equations, yet challenges everything we think we know about time itself. But before we drift into this cosmic puzzle together, take a moment to like this video if you're enjoying the calm, and subscribe if you'd like more gentle explorations of science's deepest questions. I love hearing where you're listening from and what time it is in your corner of the world. There's something magical about knowing we're all sharing this moment of wonder together, scattered across time zones but united in curiosity. Now settle in, dim the lights if you can. Maybe let that soft background hum of your fan or heater become part of tonight's soundtrack. Because what we're about to explore will bend your mind in the most soothing way possible. Imagine, if you will, a particle so strange that it moves backwards through time. A tiny messenger that could deliver tomorrow's news before today has even ended. A theoretical entity that, if it existed, would shatter our understanding of cause and effect, turning the universe into a place where endings could come before beginnings. These are tachyons, the impossible particles that break time. Tonight, we're going to unravel this beautiful paradox together, not with frantic energy or overwhelming complexity, but slowly, gently, like watching stars emerge as twilight deepens. We'll discover why these faster-than-light particles captured the imagination of physicists, why they probably can't exist in our universe, and what their mathematical ghost tells us about the nature of reality itself. You see, tachyons aren't just about exotic physics. They're about the boundaries of what's possible. They're about the delicate architecture that holds our universe together, ensuring that time flows in one direction, and that stories have proper beginnings, middles, and ends. As we explore these phantom particles, we'll touch on relativity, causality, and the profound question of whether information can ever truly travel faster than light. But here's what makes tonight's journey special. We're not rushing toward answers. We're savoring questions. Because sometimes the most beautiful truths emerge not from what exists, but from understanding why certain things cannot exist. The impossibility of tachyons is as elegant as any proof in physics, and their theoretical presence has taught us more about the structure of space-time than decades of conventional research. So breathe deeply. Let your mind become curious but calm. Tonight, we're going to discover that even impossible things can be teachers, and that sometimes the most profound insights come from particles that exist only in the realm of mathematical dreams. The story begins, as many physics tales do, with Einstein's special relativity. In 1905, a young patent clerk in Switzerland rewrote the rules of the universe with a simple but revolutionary idea. Nothing, he declared, could travel faster than light. This wasn't just a speed limit. It was a fundamental law that governed the very fabric of reality. But mathematics, as any physicist will tell you, has a mischievous sense of humor. Einstein's equations, beautiful and precise as they were, contained a peculiar loophole. While they forbade ordinary matter from accelerating to light speed, they didn't explicitly forbid the existence of particles that were already moving faster than light. These hypothetical entities would live in a realm beyond the light barrier, forever racing through space-time at superluminal speeds. For decades, this mathematical possibility remained just that, a curiosity buried in the equations. But in 1967, physicist Gerald Feinberg decided to take this curiosity seriously. He coined the term tachyon, derived from the Greek word tachys, meaning swift. Feinberg wasn't suggesting these particles existed. Rather, he was exploring what would happen if they did. What he discovered was both fascinating and deeply troubling. Tachyons, if they existed, would have the most bizarre properties imaginable. Unlike ordinary particles that slow down when they lose energy, tachyons would speed up. The less energy they carried, the faster they would go. At zero energy, they would move at infinite speed, appearing everywhere in the universe simultaneously. But the strangest property of tachyons wasn't their speed. It was their relationship with time itself. According to relativity, any observer watching a tachyon would see something impossible. The particle would appear to move backwards through time, arriving at its destination before it had departed from its origin. Picture this scene unfolding in slow motion. A tachyon is emitted from a distant star. From our perspective on Earth, we would first detect its arrival, then watch it travel backwards along its path, finally witnessing its creation at the star. The effect would precede the cause. The message would arrive before it was sent. This temporal reversal isn't science fiction. It's a direct consequence of Einstein's equations when applied to faster-than-light motion. The mathematics is unforgiving and precise. If tachyons existed, causality itself would become negotiable. Imagine you could send a tachyon message to your past self. Perhaps you'd warn yourself about an upcoming exam or a relationship that wouldn't work out. But here's where the paradoxes begin to multiply like reflections in facing mirrors. If your past self receives the warning and changes course, then the future that prompted you to send the warning would never occur. But if that future never occurs, then the warning would never be sent. But if the warning is never sent, then the original timeline would unfold, leading to the future where you decide to send the warning. This is the grandfather paradox in its purest form, extended into the realm of particle physics. Tachyons don't just challenge our understanding of speed or energy, they threaten the logical consistency of the universe itself. And yet, for a brief moment in physics history, some scientists wondered if nature might actually permit such strangeness. After all, quantum mechanics had already shown us that reality at its smallest scales was far stranger than our everyday intuition suggested. Particles could exist in multiple states simultaneously. They could be entangled across vast distances, influencing each other instantaneously. Perhaps faster-than-light particles were just another layer of cosmic weirdness waiting to be discovered. The search began in earnest. Physicists looked for tachyon signatures in cosmic ray showers, in particle accelerator experiments, in the depths of space. They developed ingenious detection schemes and searched through decades of data. If tachyons were being produced in high-energy collisions or streaming through space from distant galaxies, surely some trace would reveal itself. But the universe remained stubbornly silent. No tachyon was ever detected. No faster-than-light signal was ever confirmed. The cosmic speed limit held firm, as it had since Einstein first proposed it. This absence of evidence slowly transformed into evidence of absence. The failure to find tachyons wasn't just disappointing, it was illuminating. It suggested that the universe had built-in protections against causality violations, mechanisms that prevented the logical structure of reality from unraveling. But the story of tachyons was far from over. Even as experimental searches came up empty, theoretical physicists began to understand something profound. The impossibility of tachyons was teaching them about the deep architecture of space-time itself. You see, in the strange realm of quantum field theory, particles aren't just little balls bouncing around in empty space. They're excitations in invisible fields that permeate all of reality. Every type of particle corresponds to its own field. The electromagnetic field gives rise to photons. The electron field gives rise to electrons. And if tachyons existed, they would correspond to their own tachyonic field. But here's where the mathematics becomes beautiful and terrifying in equal measure. A field that could produce tachyons would be fundamentally unstable. It would be like trying to balance a pencil on its point. The slightest disturbance would cause it to topple, and in toppling, it would release enormous amounts of energy. This instability isn't a minor technical problem. It's a fundamental feature that would prevent tachyonic fields from existing in the first place. Nature, it seems, abhors not just a vacuum, but also the possibility of causality violation. The mathematics revealed something even more profound. In certain theoretical frameworks, particularly string theory, tachyonic fields do appear in the equations, but rather than representing faster-than-light particles, they signal that the theory is describing an unstable configuration of reality itself. The presence of tachyons in these equations is like a warning light on a dashboard, indicating that the system is trying to collapse into a more stable state. This realization transformed how physicists think about tachyons. They're not exotic particles waiting to be discovered. They're mathematical guardians, alerting us when our theories have wandered into impossible territory. Their very impossibility serves as a guide, pointing us toward the stable, consistent structures that can actually exist in our universe. As we drift deeper into this exploration, a profound picture begins to emerge. The universe isn't just a collection of particles and forces operating in empty space. It's a carefully balanced system where every law, every limitation, every impossibility serves a purpose. The ban on faster-than-light travel isn't arbitrary. It's essential to maintaining the logical consistency that allows reality to make sense. Tachyons, in their impossible existence, reveal the invisible architecture that holds everything together. They show us that the universe has a built-in wisdom, a deep intelligence that prevents paradoxes from unraveling the fabric of causality. Tonight, as you settle into rest, consider this beautiful impossibility. Somewhere in the realm of mathematical possibility, tachyons race backwards through time, carrying messages from futures that will never be. They exist only in equations, only in thought experiments, only in the careful calculations of physicists exploring the boundaries of what can be. But in their impossibility, they've taught us something precious about the universe we inhabit. They've shown us that reality has rules not to constrain us, but to protect the very possibility of meaning itself. Without the cosmic speed limit, without the prohibition on causality violation, stories would have no structure, causes would have no effects, and the beautiful, logical progression of time would dissolve into chaos. The tachyon, impossible and eternal, stands as a guardian at the gates of paradox, ensuring that our universe remains a place where science can make sense, where experiments can teach us truth, and where the gentle flow of time carries us always forward, never back. But let's pause here for a moment and really let this sink in. Because what we've discovered about tachyons reveals something extraordinary about the nature of scientific inquiry itself. Sometimes the most profound discoveries come not from finding what we're looking for, but from understanding why we can't find it. The absence of tachyons is as meaningful as their presence would have been, perhaps more so. Think of it this way. When you're trying to solve a puzzle, sometimes the most important clue is the piece that doesn't fit. The piece that, no matter how you turn it or rotate it, simply cannot find its place in the larger picture. Tachyons are that impossible puzzle piece of physics, and in trying to understand why they don't fit, we've learned something beautiful about the puzzle itself. The universe, it turns out, is exquisitely fine-tuned for consistency. Every law of physics works in harmony with every other law, creating a symphony of cause and effect that allows reality to unfold in a logical, comprehensible way. The prohibition against faster-than-light travel isn't a limitation imposed from outside. It emerges naturally from the very structure of space-time itself. But here's where our journey takes a fascinating turn. While tachyons themselves remain impossible, the mathematical framework that describes them has found unexpected applications in modern physics. The same equations that predict causality-violating particles have helped physicists understand phase transitions, vacuum stability, and the fundamental forces that shaped the early universe. It's like discovering that a mythical creature, while it cannot exist in our world, perfectly describes the behavior of shadows cast by real animals. The mathematics of impossibility becomes a tool for understanding possibility. In string theory, those elegant equations that attempt to unify all the forces of nature, tachyonic fields play a crucial role. Not as particles that break causality, but as signals that guide the theory towards stable, consistent solutions. When a tachyon appears in a string theory calculation, it's telling physicists that the configuration they're examining is unstable and will evolve towards something more fundamental. Picture a ball rolling down a hill. The ball doesn't want to remain on the slope. It seeks the valley below, the lowest energy state where it can rest in stability. Tachyonic fields in string theory are like that ball on the slope. Their presence indicates that the system is rolling toward a more stable configuration, a deeper truth about the nature of reality. This has led to some of the most beautiful insights in modern theoretical physics. The process of tachyon condensation, as it's called, might explain how our universe acquired its current properties during the earliest moments after the Big Bang. The impossible particles that cannot exist in our world may have played a crucial role in creating the world where we do exist. Let this idea wash over you gently. The very impossibility that makes tachyons fascinating also makes them useful. They serve as mathematical compasses, always pointing toward stability, toward consistency, toward the configurations of reality that can actually sustain themselves over cosmic time. But there's an even deeper layer to this story, one that touches on the most fundamental questions of existence itself. The prohibition against faster-than-light travel isn't just about particles or fields or equations. It's about information. It's about the flow of knowledge through the universe. Consider what would happen if information could truly travel faster than light. Not just particles, but actual information, messages, signals carrying meaning from one place to another. The consequences would be far more profound than simple causality violations. They would undermine the very possibility of science itself. Science depends on the principle that experiments can teach us about the world. We observe a cause, we measure an effect, and from this sequence, we build our understanding of natural laws. But if effects could precede causes, if information could flow backwards through time, then the entire enterprise of learning from experience would collapse. A universe with tachyons would be a universe where knowledge itself becomes paradoxical. You could learn about the future before it happens, then use that knowledge to change the future, which would invalidate the knowledge you learned. The very concept of discovery, of learning, of building understanding through observation would become meaningless. In this sense, the impossibility of tachyons protects something even more fundamental than causality. It protects the possibility of knowledge itself. It ensures that the universe remains comprehensible, that science can function, that conscious beings can learn and grow and understand their place in the cosmic order. This is why physicists sometimes speak of the cosmic censorship hypothesis, the idea that the universe has built-in mechanisms to prevent paradoxes and protect causality. It's not that nature is conspiring against faster-than-light travel out of some arbitrary preference. It's that the logical structure of reality itself depends on maintaining certain boundaries. The speed of light isn't just a speed limit, it's the speed of causality itself. It's the rate at which cause and effect can propagate through space-time. When we say nothing can travel faster than light, we're really saying that nothing can outrun the fundamental logic that holds the universe together. And yet, even as we explore these deep principles, questions remain. Quantum mechanics has shown us that the universe is stranger than our classical intuitions suggest. Particles can be entangled across vast distances, their properties correlated in ways that seem to transcend the speed of light. But importantly, these quantum correlations cannot be used to send information faster than light. The cosmic speed limit remains intact, even in the weird world of quantum mechanics. This is where modern physics finds itself today, walking a tightrope between the possible and the impossible. We've discovered phenomena that challenge our everyday understanding of reality, yet they all respect the deeper logical structure that prevents paradoxes. It's as if the universe is willing to be strange, even impossibly strange, but only within limits that preserve its fundamental consistency. The story of tachyons embodies this tension beautifully. They represent the edge of what mathematics can imagine and what reality can permit. They live in the space between possibility and impossibility, serving as eternal guardians of the logical order that makes science possible. As we continue our gentle exploration tonight, let yourself marvel at this delicate balance. The universe could have been chaotic, arbitrary, impossible to understand. Instead, it chose to be strange but consistent, mysterious but logical, filled with wonders that challenge our minds while respecting the deeper principles that allow our minds to function at all. In the quiet of this moment, as you rest and reflect, consider the profound gift that the impossibility of tachyons represents. It's the gift of a universe that makes sense, where time flows forward, where causes precede effects, where learning is possible and knowledge can accumulate across generations. The particles that cannot exist have taught us why the particles that do exist can tell coherent stories about the cosmos. Tomorrow, if we could send a message to yesterday, we would discover something unsettling about the nature of knowledge itself. But let's approach this gently, like watching ripples spread across a still pond at twilight. The mathematics of tachyons reveals a peculiar truth about our universe. These impossible particles don't just violate causality in simple ways. They create what physicists call closed, time-like curves, pathways through space-time that loop back on themselves. Imagine drawing a circle in time itself, where the end connects to the beginning, where every moment contains all other moments. In such a universe, prediction becomes meaningless. How can you forecast tomorrow when tomorrow has already influenced yesterday? How can you make a choice when the consequences of that choice reach backwards to affect the very conditions that led to the choice? The logical foundation of decision-making dissolves into paradox. This isn't merely a philosophical curiosity. It strikes at the heart of what makes consciousness possible. Our minds operate by processing information sequentially, building understanding moment by moment, thought by thought. Memory stores the past, attention focuses on the present, and imagination projects into the future. But in a world where tachyons carry information backwards through time, this careful sequence collapses. Consider the simple act of learning something new. You observe a phenomenon, form a hypothesis, test it against reality, and refine your understanding. This process depends absolutely on the arrow of time. The observation must precede the hypothesis. The test must follow the prediction. Remove this temporal ordering, and learning becomes impossible. Knowledge transforms from a tool for understanding reality into a source of infinite confusion. The prohibition against faster-than-light information transfer isn't just protecting causality, it's protecting the very possibility of minds like ours existing in the first place. Consciousness itself seems to require a universe where cause and effect flow in one direction, where memory can store the past without being contaminated by echoes from the future. But let's drift deeper into this mystery, because the story of tachyons connects to something even more fundamental about the architecture of reality. The equations that forbid these impossible particles also reveal why the universe chose the particular structure it did. You see, there are many ways a universe could be organized. The laws of physics could have taken countless different forms. Yet, our universe settled on a very specific set of rules. Rules that permit complexity to emerge while maintaining logical consistency. The speed of light emerges from these rules not as an arbitrary constant, but as a natural consequence of the way space and time are woven together. When Einstein first proposed that space and time were unified into a single fabric called spacetime, he wasn't just solving problems in physics. He was revealing that the universe has an inherent geometry, a shape that determines what kinds of motion are possible and what kinds of information can flow from one place to another. This geometry is subtle but profound. It ensures that every observer, no matter how they're moving, will measure the same speed of light. It guarantees that cause and effect maintain their proper relationship. It creates a framework within which complex structures like stars, planets, and living beings can form and persist across cosmic time. The mathematics that describes this geometry contains no room for tachyons, not because mathematicians decided to exclude them, but because the geometric structure of space-time itself makes them impossible. It's like trying to draw a square circle or find the largest integer. The contradiction isn't in our understanding, but in the nature of the request itself. This geometric impossibility has guided physicists towards some of their deepest insights. When quantum field theory predicted the existence of tachyonic fields in certain configurations, physicists knew immediately that these configurations couldn't represent stable reality. The presence of tachyons served as a diagnostic tool, revealing which theoretical possibilities could actually exist and which were mathematical mirages. In string theory, this principle has become one of the most powerful guides for understanding the fundamental structure of reality. String theorists use tachyon condensation to explore how the universe might have evolved from more symmetric but unstable configurations into the asymmetric but stable reality we observe today. Picture the early universe as a perfectly symmetric crystal, beautiful in its mathematical purity, but fundamentally unstable. The presence of tachyonic modes in such a system would signal that this perfect symmetry cannot last. The crystal must break, must settle into a less symmetric but more stable configuration. And in that breaking, in that settling, the rich structure of our current universe emerges. The particles that cannot exist become the sculptors of what can exist. Their impossible presence in the equations guides reality toward configurations that exclude them, toward the stable, consistent patterns that can persist across billions of years of cosmic evolution. This process of guided evolution through impossibility reveals something beautiful about the relationship between mathematics and reality. Mathematics doesn't just describe the universe as it is. It explores the universe as it could be, mapping out all possibilities, including the impossible ones. And in exploring these impossible territories, mathematics reveals why reality chose the particular path it did. The equations that predict tachyons also predict their own inconsistency. They contain within themselves the seeds of their own correction. It's as if mathematics has a built-in wisdom, an ability to recognize when it has wandered into forbidden territory and to guide itself back toward truth. This self-correcting aspect of mathematical physics has profound implications for how we understand the universe. It suggests that reality isn't arbitrary, that the laws of physics aren't just historical accidents that happen to emerge in our particular corner of existence. Instead, they represent something like logical necessities, patterns that emerge naturally from the deeper requirements of consistency and stability. The impossibility of tachyons is part of this larger pattern. Their absence isn't a limitation imposed on the universe from outside. It's a consequence of the universe's own internal logic, its commitment to remaining comprehensible and consistent across all scales of space and time. As we contemplate this tonight, let yourself feel the quiet satisfaction of understanding something profound about the nature of existence. The universe we inhabit isn't just a collection of random phenomena held together by arbitrary rules. It's a carefully orchestrated symphony of cause and effect, a logical structure so elegant that it excludes its own contradictions. The particles that race backwards through time exist only in our equations, only in our thought experiments, only in the careful explorations of what cannot be. But in their impossible journey, they illuminate the possible. They reveal the necessary. They show us why reality chose to be the way it is, rather than any other way it might have been. In the gentle darkness of this moment, as your mind processes these ideas and your body settles into rest, consider the profound gift of inhabiting a universe that makes sense. A universe where time flows forward, where learning is possible, where consciousness can emerge and flourish and contemplate its own existence. The tachyons that cannot exist have taught us to appreciate the particles that can. The messages that cannot travel backwards through time have shown us the beauty of messages that flow forward, carrying information and meaning and stories from one moment to the next, building the rich tapestry of experience that makes life worth living. But our exploration of these impossible particles reveals yet another layer of mystery, one that touches on the very foundations of how we understand reality itself. The mathematical frameworks that forbid tachyons also suggest that our universe might be just one of many possible universes, each with its own set of physical laws, its own constraints on what can and cannot exist. In some of these hypothetical universes, the mathematics might permit different kinds of particles, different relationships between cause and effect, different speeds of information transfer. Perhaps there are universes where tachyons can exist because the very structure of spacetime is organized differently, where consciousness has evolved to operate in ways we cannot imagine, where the flow of time itself follows patterns that would seem impossible to us. This multiverse perspective doesn't make tachyons any more possible in our universe, but it does suggest that the impossibility we've discovered is specific to the particular reality we inhabit. The cosmic speed limit, the prohibition against causality violation, the protection of temporal logic, these aren't universal absolutes that apply everywhere and every when. They're features of our universe, consequences of the specific way our space-time is structured. This realization brings a kind of cosmic humility. The rules that govern our reality, fundamental as they seem to us, might be local ordinances in a vast multiverse of possibilities. The tachyons that cannot exist here might race freely through other realms of existence, carrying their impossible messages backwards through alien forms of time. Yet even this humbling perspective doesn't diminish the profound importance of understanding our own universe's constraints. Whether or not tachyons exist elsewhere, they cannot exist here. Whether or not causality operates differently in other realities, it operates in a specific way in ours. And that specific way is what makes our existence possible. The absence of tachyons in our universe is intimately connected to the presence of everything else we value. The forward flow of time that makes growth and learning possible. The causal structure that allows for meaningful choices and consequences. The logical consistency that enables science to function and knowledge to accumulate. In exploring the impossible, we've discovered the necessary. In understanding why certain things cannot exist, we've learned to appreciate why the things that do exist are so precisely suited to supporting the emergence of complexity, consciousness, and wonder. Tonight, as these ideas settle into your mind like snow falling on a quiet landscape, let yourself marvel at this cosmic coincidence. That in a universe of infinite mathematical possibilities, we find ourselves in one of the rare configurations where minds can emerge, where thoughts can form, where impossible particles can be imagined, even as they're excluded from reality. The tachyons that break time exist only in our imagination, but our imagination exists because time flows unbroken. The messages that cannot travel backwards through time have made possible the consciousness that can dream of sending them. The particles that violate causality live only in equations that causality makes possible to write. In this profound circularity, we find something almost poetic about the nature of scientific discovery. The very tools we use to explore the impossible are made possible by the impossibility we're exploring. Our equations can describe tachyons precisely because tachyons cannot disrupt the logical framework that makes equations meaningful. Our minds can contemplate causality violation because causality violation cannot unmake the minds that contemplate it. This brings us to one of the most beautiful aspects of theoretical physics. Sometimes the deepest truths emerge not from observing what exists, but from carefully reasoning about what cannot exist. The mathematician who proves that certain infinite sets cannot be constructed learns something profound about the nature of infinity itself. The physicist who demonstrates why certain particles cannot exist discovers fundamental principles about the structure of reality. Tachyons belong to this special category of impossible things that teach us about the possible. They're like mathematical koans, paradoxes that guide us toward enlightenment about the true nature of spacetime. In trying to understand why they cannot exist, we've uncovered the hidden architecture that makes everything else possible. Consider how elegantly this works. The same relativistic principles that forbid faster-than-light travel also explain how GPS satellites maintain accurate time, how particle accelerators function, how the sun converts mass into energy. The prohibition against tachyons is woven into the same mathematical fabric that describes the most practical technologies in our world. It's as if the universe operates on a principle of elegant consistency. Every law serves multiple purposes. Every constraint enables multiple freedoms. The cosmic speed limit that prevents causality violation also determines how electromagnetic fields propagate, how gravity waves ripple through spacetime, how information can flow between distant galaxies. This interconnectedness reveals something profound about the nature of physical law. These aren't arbitrary rules imposed by some cosmic legislator. They're emergent properties of a deeper logical structure, patterns that arise naturally when consistency is maintained across all scales of existence. The mathematics that predicts tachyons also predicts their own instability. It's a self-correcting system, like a compass that always points toward truth, even when we try to aim it toward falsehood. The equations themselves guide us away from inconsistency and toward the stable configurations that can actually exist. But let's pause here and consider something even more mysterious. Why should mathematics have this almost magical ability to describe reality at all? Why should the abstract symbols we manipulate on paper correspond so precisely to the behavior of particles we've never seen, forces we cannot directly feel, phenomena that occur at scales vastly larger or smaller than human experience? The story of tachyons illuminates this mystery in a unique way. Here we have mathematical entities that correspond to nothing in physical reality, yet their mathematical properties tell us profound truths about the physical world. The equations that describe these non-existent particles reveal why existing particles behave the way they do. It's as if mathematics contains a kind of negative space, regions that describe what cannot be, but in doing so, illuminate what can be. The mathematical description of impossible motion reveals the necessary constraints on possible motion. The equations for non-existent particles explain the behavior of existing ones. This suggests something deep about the relationship between mind and cosmos. Our mathematical intuitions, evolved in a world of medium-sized objects moving at modest speeds, somehow manage to capture truths about realms far beyond direct experience. The same logical principles that help us navigate daily life also reveal the fundamental structure of space-time itself. Perhaps consciousness, and cosmos are more intimately related than we typically imagine. Perhaps the universe is not just mathematically describable, but mathematical in its very essence. The patterns we discover in our equations might not be human inventions projected onto an alien reality, but rather glimpses of the logical structure that reality itself embodies. If this is true, then the impossibility of tachyons takes on an even deeper significance. They represent places where the mathematical structure of reality prohibits certain configurations. They're like grammatical rules in the language of existence, constraints that ensure the cosmic conversation makes sense. The universe, in this view, is engaged in an ongoing act of self-description. Every physical process is like a sentence in an immense cosmic narrative. The laws of physics are the grammar that ensures this narrative remains coherent, and tachyons represent grammatical errors that the universe automatically corrects. This perspective transforms our understanding of what it means to do physics. We're not just passive observers of an external reality, we're participants in the universe's ongoing act of self-comprehension. When we write equations that describe impossible particles, we're helping the cosmos explore its own logical boundaries. The fact that our minds can conceive of tachyons, even while reality excludes them, suggests a deep kinship between consciousness and the mathematical structure of existence. We can imagine what cannot be because we're made of the same logical stuff that determines what can be. In the quiet of this moment, let this idea settle gently into your awareness. You are not separate from the universe you're contemplating. You are the universe contemplating itself. Your capacity to understand why tachyons cannot exist is itself a manifestation of the same cosmic intelligence that ensures they cannot exist. The thoughts forming in your mind right now are part of the same vast pattern that includes the motion of galaxies, the dance of subatomic particles, the flow of time itself. Your wonder at the impossibility of faster-than-light communication is itself a form of cosmic communication. The universe sharing its deepest secrets with itself through the medium of your consciousness. But this cosmic perspective doesn't diminish the practical importance of understanding these impossibilities. The principles that forbid tachyons have concrete implications for technology, for exploration, for our understanding of what kinds of communication and travel are possible across the vast scales of space and time. When we design experiments to test the limits of quantum entanglement, we're guided by our understanding of why information cannot travel faster than light. When we plan missions to distant stars, we accept the constraint that no signal can outrun light itself. When we search for extraterrestrial intelligence, we know that any messages from alien civilizations must respect the cosmic speed limit. These practical constraints, rooted in the same mathematics that excludes tachyons, shape our approach to some of the most ambitious projects in human history. The impossibility of faster-than-light communication determines the fundamental challenges of interstellar exploration. The prohibition against causality violation sets the ultimate limits on computation and information processing. Yet even within these constraints, the universe offers remarkable possibilities. Quantum entanglement allows for correlations that seem to transcend space and time, even though they cannot be used for faster-than-light communication. Gravitational waves carry information across cosmic distances at precisely the speed of light, opening new windows onto the most violent events in the universe. The curvature of spacetime itself offers subtle loopholes in our naive understanding of distance and travel time. While nothing can move through space faster than light, space itself can expand, contract, and curve in ways that create shortcuts and delays. The universe is strange enough without requiring the additional strangeness of tachyons. As we drift deeper into this exploration, notice how the impossibility of faster-than-light particles connects to the broader theme of cosmic fine-tuning. the universe seems to be organized in a way that permits maximum richness and complexity while maintaining logical consistency. If tachyons existed, the resulting causality violations would prevent the formation of stable structures. Stars couldn't form in a predictable way if their nuclear processes could be influenced by future events. Planets couldn't maintain stable orbits if gravitational effects could propagate backwards through time. Life couldn't evolve if the arrow of time could be reversed. The absence of tachyons is part of a larger pattern of cosmic constraints that enable, rather than limit, the emergence of complexity. The finite speed of light creates a natural isolation between distant regions of space, allowing different areas to evolve independently. The forward flow of time enables the accumulation of information and the growth of structure. The prohibition against causality violation protects the logical foundation that makes evolution possible. In this sense, the impossibility of tachyons is one of the hidden gifts that makes our existence possible. We inhabit a universe that is strange enough to support the emergence of consciousness, but not so strange that consciousness cannot function. The cosmic speed limit is part of the delicate balance that allows minds to emerge from matter. Tonight, as your own mind processes these ideas, you're experiencing the fruits of this cosmic balance. Your thoughts unfold in sequence, building understanding moment by moment. Your memories preserve the past without being corrupted by echoes from the future. Your ability to reason about cause and effect depends on the same logical structure that excludes faster-than-light particles. The tachyons that cannot exist have taught us to appreciate the thoughts that can exist. The messages that cannot travel backwards through time have shown us the beauty of consciousness, moving forward through time, accumulating wisdom, building understanding, reaching toward truth. In the gentle darkness of this moment, as your body rests and your mind wanders through these cosmic mysteries, feel the profound interconnectedness of all things. The same principles that govern the motion of galaxies govern the formation of your thoughts. The same logic that excludes impossible particles enables possible consciousness. You are part of a universe that chose consistency over chaos, meaning over paradox, the beautiful constraints that make beauty possible over the unlimited freedom that would make nothing possible at all. The particles that break time exist only in equations that time makes possible to write, and those equations exist only in minds that time makes possible to form. So let's drift deeper into this cosmic puzzle, because there's something almost poetic about how the universe protects itself from paradox. Imagine reality as a vast interconnected web where every thread must maintain its proper tension. Pull too hard on one strand and the entire structure could unravel. Tachyons represent the kind of pulling that would tear the web apart. The mathematics reveals this protection in the most elegant way. When physicists first explored what would happen if faster-than-light particles existed, they discovered that such particles would carry what's called imaginary mass. Not imaginary in the sense of being fictional, but imaginary in the precise mathematical sense, involving the square root of negative numbers. This isn't just a quirky mathematical detail, it's a profound statement about the nature of reality itself. In the language of physics, imaginary mass signals instability so fundamental that it prevents the very formation of the particles that would possess it. It's like the universe saying, I can conceive of these entities mathematically, but I cannot allow them to exist physically. Picture a soap bubble forming in slow motion. For a brief instant, the surface tension creates a perfect sphere, beautiful and delicate. But if you try to make the bubble too large or stretch it beyond its natural limits, it doesn't just resist, it pops completely, returning to a state where bubbles are possible, but oversized ones are not. Tachyonic fields behave similarly, collapsing before they can produce the particles that would violate causality. This collapse process, known as tachyon condensation, has become one of the most beautiful examples of how mathematics guides physics toward truth. When a theoretical framework predicts tachyons, physicists know immediately that they're looking at an unstable configuration that must evolve towards something more fundamental. It's like watching a river find its course down a mountainside. The water doesn't fight the landscape. It flows naturally toward the lowest energy state, carving channels that become more stable with time. Tachyonic fields flow similarly, seeking configurations that exclude the very particles that would make them impossible. But here's where the story becomes even more intriguing. In the early universe, during those first moments after the Big Bang, conditions might have been so extreme that tachyonic fields played a crucial role in shaping the reality we now inhabit. Not as stable particles racing through space, but as transitional states that guided the cosmos toward its current configuration. Think of the early universe as a vast symphony orchestra tuning their instruments. At first, there's cacophony, discord, mathematical noise. But gradually, through processes we're only beginning to understand, harmony emerges. The tachyonic modes in those early moments might have been like a cosmic conductor, guiding the symphony of space and time toward the beautiful, consistent music we hear today. This perspective transforms our understanding of what impossibility means in physics. The things that cannot exist aren't failures of nature's imagination. They're stepping stones in nature's creative process, temporary configurations that guide reality toward more stable and beautiful forms. Consider how this applies to the very fabric of space-time itself. Einstein's equations suggest that space and time are not fixed backdrops against which events unfold. They're dynamic entities that can stretch, compress, and vibrate, but they cannot stretch or compress in ways that would permit faster-than-light travel. The geometry of spacetime itself conspires to maintain the cosmic speed limit. This isn't a limitation imposed from outside. It's an intrinsic property of the geometric structure that space and time share. Imagine trying to draw a triangle on the surface of a sphere where the angles add up to more than 180 degrees. The geometry itself makes certain configurations impossible, not through force, but through the fundamental nature of curved space. The prohibition against tachyons emerges from this same geometric necessity. Space-time has a structure, a shape, a mathematical architecture that determines what kinds of motion are possible and what kinds are forbidden. The cosmic speed limit isn't a rule written in some celestial law book. It's woven into the very fabric of existence. But let's explore something even more mysterious. If tachyons cannot exist in our universe, why do they appear so naturally in our mathematical descriptions of reality? Why do the equations that describe the deepest levels of physics spontaneously generate these impossible entities? The answer reveals something profound about the relationship between mathematics and physical truth. Mathematics doesn't just describe what is, it maps out what could be, including the vast territories of what cannot be. In exploring these impossible territories, mathematics reveals why reality chose the particular path it did. Think of mathematics as a vast library containing every possible book. Most of these books are nonsense, random arrangements of letters that convey no meaning. But scattered throughout the library are books that tell coherent stories, books that describe possible worlds, books that reveal truth about the nature of existence. The mathematical descriptions of tachyons are like books in this library that begin coherently but gradually dissolve into paradox. They start with sensible premises but lead to impossible conclusions. In following these mathematical narratives to their paradoxical ends, we learn something crucial about what makes the coherent stories possible. The equations that predict tachyons also predict their own inconsistency. They contain within themselves the seeds of their own correction. It's as if mathematics has a built-in immune system that recognizes contradiction and guides itself back toward truth. This self-correcting aspect of mathematical physics has guided some of the most important discoveries in modern science. When quantum field theory first predicted the existence of antiparticles, the mathematics seemed to be generating impossible entities, particles with negative energy, solutions that made no physical sense. But rather than dismissing these mathematical artifacts, physicists followed them to their logical conclusion and discovered antimatter. The difference between antiparticles and tachyons is subtle but crucial. Antiparticles, while initially seeming impossible, turn out to be consistent with the deeper logical structure of reality. They don't violate causality or create paradoxes. Tachyons, by contrast, lead inevitably to contradictions that cannot be resolved within any consistent framework. This distinction has taught physicists to trust the mathematics while remaining vigilant about consistency. When equations predict something that seems impossible, the question isn't whether to believe the mathematics, but whether the mathematical framework itself is describing a stable configuration of reality. Tachyons have become the ultimate test of this principle. Their presence in any theoretical framework is like a canary in a coal mine, warning that the theory has wandered into unstable territory. They serve as mathematical guardians, protecting the logical consistency that makes physics possible. But there's something almost mystical about how this protection works. The universe doesn't need to actively enforce the prohibition against faster-than-light particles. The prohibition emerges naturally from the mathematical structure of spacetime itself. It's as if reality has a built-in wisdom that prevents its own logical contradiction. This brings us to one of the deepest questions in all of physics. Why should the universe be mathematically comprehensible at all? Why should the abstract patterns we discover in our equations correspond so precisely to the behavior of physical systems? The story of tachyons illuminates this mystery in a unique way. Here, we have mathematical entities that correspond to nothing in physical reality, yet their mathematical properties reveal profound truths about the physical world. The equations for non-existent particles explain the behavior of existing ones. The mathematics of impossible motion reveals the necessary constraints on possible motion. It's as if mathematics contains a kind of negative space, regions that describe what cannot be, but in doing so illuminate what can be. The mathematical landscape includes vast territories of impossibility, and by mapping these territories, we come to understand the small islands of possibility where reality actually resides. Tonight, as you rest in the quiet darkness, let this idea settle gently into your awareness. The universe you inhabit is not just one of many possible universes. It's one of the rare configurations where mathematics and reality align in perfect harmony, where consciousness can emerge to contemplate its own existence, where impossible particles can be imagined even as they're excluded from reality. The tachyons that break time exist only in our mathematical imagination, but our mathematical imagination exists because time flows unbroken. The particles that violate causality live only in equations that causality makes possible to write. The messages that cannot travel backwards through time have made possible the consciousness that can dream of sending them. In this profound circularity, we find something almost sacred about the nature of scientific discovery. The very tools we use to explore the impossible are made possible by the impossibility we're exploring. Our minds can contemplate faster-than-light travel because faster-than-light travel cannot disrupt the logical framework that makes contemplation possible. Consider the elegant recursion at work here. The universe generates conscious beings capable of discovering why certain things cannot exist in the universe. The cosmos creates minds that can understand their own cosmic constraints. Reality produces observers who can observe the boundaries of what reality permits. This suggests that consciousness and cosmos are not separate entities, but aspects of a single, self-exploring system. When you understand why tachyons cannot exist, you're not just learning about exotic physics, you're participating in the universe's ongoing act of self-comprehension. The thoughts forming in your mind right now are part of the same vast pattern that includes the motion of galaxies, the dance of subatomic particles, the flow of time itself. Your wonder at the impossibility of faster-than-light communication is itself a form of cosmic communication, the universe sharing its deepest secrets with itself through the medium of your consciousness. But let's not lose ourselves entirely in cosmic poetry. The practical implications of these insights are equally profound. Understanding why tachyons cannot exist guides our approach to some of the most ambitious projects in human history. The search for extraterrestrial intelligence, the design of quantum computers, the planning of interstellar missions all depend on respecting the cosmic speed limit that tachyons would violate. When we design experiments to test the foundations of quantum mechanics, we're guided by our understanding of why information cannot travel faster than light. When we explore the possibilities of quantum entanglement for secure communication, we work within the constraints that prevent causality violation. When we dream of technologies that might seem to transcend the speed of light, we ensure they operate through mechanisms that actually respect it. The impossibility of tachyons doesn't limit our technological aspirations, it focuses them. By understanding what cannot be achieved, we can direct our efforts toward what can be achieved. The cosmic speed limit becomes not a barrier to overcome, but a design principle to embrace. Think of how architects work within the constraints of gravity, materials, and space to create structures of stunning beauty and functionality. They don't fight these constraints. They use them as creative guides, allowing limitations to inspire innovation. Similarly, physicists and engineers work within the constraints imposed by relativity to create technologies that seemed impossible just decades ago. GPS satellites maintain nanosecond precision by accounting for relativistic time dilation. Particle accelerators probe the fundamental structure of matter by respecting the relationship between energy and mass. Medical imaging devices peer inside the human body using principles derived from the same equations that forbid faster-than-light travel. The mathematical framework that excludes tachyons includes these practical applications as natural consequences. The same geometric structure of spacetime that prevents causality violation also enables gravitational lensing, which allows us to see distant galaxies. The same relativistic principles that forbid time travel also explain how matter converts to energy in the cores of stars. This interconnectedness reveals something beautiful about the architecture of physical law. Every constraint enables multiple possibilities. Every limitation opens new doors. The cosmic speed limit that prevents tachyons also determines how electromagnetic fields propagate, how gravitational waves ripple through space, how information can flow between distant galaxies. As your mind processes these connections tonight, you're experiencing the fruits of this cosmic architecture. Your thoughts unfold in sequence, building understanding moment by moment. Your memories preserve the past without being corrupted by echoes from the future. Your ability to reason about cause and effect depends on the same logical structure that excludes impossible particles. The neurons in your brain operate according to the same relativistic principles that govern the motion of spacecraft. The electrical signals that carry your thoughts respect the same speed limits that constrain cosmic communication. Even the biochemical processes that sustain your life unfold within the temporal framework that makes tachyons impossible. You are not separate from the physics you're contemplating. You are physics contemplating itself. Your capacity to understand why certain particles cannot exist is itself a manifestation of the cosmic intelligence that ensures they cannot exist. Your wonder at these impossibilities is the universe wondering at its own logical structure. In the gentle quiet of this moment, feel the profound interconnectedness of all things. The same principles that govern the expansion of the universe govern the expansion of your understanding. The same logic that excludes faster-than-light particles enables the slower-than-light processes that constitute your consciousness. The tachyons that cannot exist have taught us to appreciate the thoughts that can exist. The messages that cannot travel backwards through time have shown us the beauty of consciousness moving forward through time, accumulating wisdom, building understanding, reaching toward truth. But our journey with these impossible particles isn't quite complete. There's one more layer to this mystery, one that touches on the deepest questions about the nature of time itself. Because in exploring why tachyons cannot exist, we've discovered something profound about why time has the particular character it does in our universe. Time, as we experience it, has a direction. We remember the past, but not the future. We can influence what happens next, but not what happened before. Causes precede effects in a reliable, consistent way. This temporal asymmetry seems so natural to us that we rarely question why it should be this way at all. But the fundamental equations of physics are largely symmetric with respect to time. Most physical processes can, in principle, run backwards just as easily as forwards. A movie of two billiard balls colliding would look equally plausible, whether played forward or in reverse. So where does the arrow of time come from? The prohibition against tachyons offers a clue to this deep mystery. By preventing information from traveling backwards through time, the cosmic speed limit helps maintain the very asymmetry that gives time its direction. Without this prohibition, the careful distinction between past and future would dissolve into paradox. Imagine a universe where tachyons could exist. Information from the future would constantly leak into the past. Effects would precede their causes in an endless web of circular causation. The clean arrow of time that allows for memory, learning, and growth would become tangled beyond recognition. In such a universe, consciousness as we know it could not exist. Our minds depend absolutely on the ability to process information sequentially, to build understanding moment by moment, to remember the past while remaining ignorant of the future. Remove this temporal structure, and the very possibility of coherent thought disappears. The absence of tachyons is therefore intimately connected to the presence of consciousness. The cosmic speed limit that prevents faster-than-light communication also protects the temporal framework within which minds can function. The impossibility of time travel helps preserve the possibility of beings who can think about time travel. This connection between cosmic constraints and consciousness suggests something profound about the nature of the universe we inhabit. We don't just happen to live in a cosmos that permits the emergence of minds. We live in a cosmos that seems almost designed to support the emergence of minds, with constraints that enable rather than limit the growth of complexity and understanding. The prohibition against tachyons is part of this larger pattern of cosmic fine-tuning. The universe appears to be organized in a way that permits maximum richness and complexity while maintaining logical consistency. Every law serves multiple purposes. Every constraint enables multiple freedoms. Consider how elegantly this works. The same relativistic principles that forbid faster-than-light travel also explain how stars shine, how black holes form, how the universe expands. The mathematics that excludes tachyons also describes the behavior of GPS satellites, the operation of particle accelerators, the propagation of electromagnetic waves. It's as if the universe operates on a principle of elegant economy, where every fundamental rule serves multiple functions in maintaining the cosmic order. The prohibition against causality violation doesn't just prevent logical contradictions, it creates the temporal framework within which evolution can operate, within which consciousness can emerge, within which science itself becomes possible. Tonight, as these ideas flow through your awareness like a gentle stream, let yourself appreciate the profound gift of inhabiting such a universe. A cosmos that is strange enough to inspire wonder, but not so strange that wonder becomes impossible. A reality that permits the emergence of minds capable of contemplating their own cosmic context. The tachyons that cannot exist have taught us about the delicate balance that makes existence possible. They've shown us that the universe is not arbitrary chaos, but a carefully orchestrated symphony of possibility and constraint. They've revealed that consciousness is not an accident, but a natural flowering of cosmic principles that protect the very conditions consciousness requires. In understanding why certain things cannot be, we've learned to appreciate why the things that are have the particular character they do. The particles that break time exist only in equations that time makes possible to write, and those equations exist only in minds that time makes possible to form. As you drift toward rest tonight, carry with you this sense of cosmic harmony. You are not a stranger in an alien universe, but a natural expression of cosmic principles that have been unfolding for billions of years. Your thoughts are not separate from the physics that governs stars and galaxies, but are themselves physics in one of its most beautiful forms. The impossible particles that fascinated us tonight will continue their eternal journey through the realm of mathematical possibility, forever racing backwards through imaginary time, forever teaching us about the real time in which we actually live. They are companions in the great adventure of understanding, guides that point us always toward truth by showing us the territories where truth cannot be found. And in the morning, when you wake to a universe where cause precedes effect, where time flows forward, where consciousness can build understanding moment by precious moment, perhaps you'll remember these mathematical ghosts that helped illuminate the logical architecture of reality itself. The tachyons that cannot exist, but in their impossibility, make everything else possible. But perhaps the most beautiful insight that emerges from our journey with tachyons comes when we step back and see the larger picture they've painted for us. These impossible particles have served as our guides through a landscape of cosmic logic, showing us not just what cannot be, but illuminating why what is has the precise character it does. In the quiet of this moment, as your breath settles into its natural rhythm, consider how tachyons have revealed the universe to be something far more elegant than a random collection of particles and forces. We've discovered a cosmos that operates like a vast, self-correcting system where every apparent possibility is tested against the deeper requirements of consistency and meaning. The mathematics that describes tachyons doesn't just predict their impossibility, it explains why their impossibility is necessary for everything else we value to exist. The same equations that forbid faster-than-light travel also ensure that information can accumulate over time, that learning is possible, that consciousness can emerge and flourish in a universe that makes sense. Think of it as cosmic grammar, the deep syntax that ensures reality tells a coherent story. Tachyons represent grammatical errors in the language of existence, violations of the underlying logic that would render the entire cosmic narrative meaningless. Their absence isn't a limitation, but a protection, safeguarding the very possibility of meaning itself. This protection operates at every level of reality. In the quantum realm, where particles dance between existence and possibility, the prohibition against faster-than-light signaling ensures that the strange correlations of entanglement cannot be used to send information backwards through time. The weirdness of quantum mechanics is permitted, even encouraged, but only within boundaries that preserve causality. At the cosmic scale, where galaxies drift apart on the expanding fabric of spacetime, the same principles ensure that no signal can outrun the universal expansion. Even as space itself stretches faster than light, carrying distant galaxies beyond our observable horizon, no information travels with that expansion. The cosmic speed limit remains inviolate even as the cosmos itself grows. And in the realm of consciousness, where thoughts unfold and understanding grows, these same constraints create the temporal framework within which minds can function. Your ability to process these ideas right now depends on the forward flow of time that tachyons would disrupt. Every moment of insight, every connection between concepts, every gentle deepening of understanding relies on the logical structure that excludes impossible particles. The beauty of this cosmic architecture becomes even more apparent when we consider how it enables, rather than constrains, creativity. Artists work within the limitations of their medium to create beauty. Musicians work within the constraints of harmony and rhythm to compose symphonies. Scientists work within the boundaries of physical law to discover truth. Similarly, the universe works within the constraints of logical consistency to generate endless creativity and complexity. The prohibition against tachyons is part of a larger framework of cosmic principles that channel the raw energy of existence into stable, meaningful patterns. Stars, planets, life, consciousness, all emerge from this careful balance between freedom and constraint. Tonight, as you rest in this understanding, let yourself feel the profound security of inhabiting a universe that knows its own limits. The cosmic speed limit isn't a barrier to transcendence, but a foundation for it. By preventing the chaos that would result from causality violation, it creates space for the ordered complexity that makes transcendence possible. Your thoughts, forming and flowing in the gentle darkness, are themselves a form of cosmic transcendence. Matter has organized itself into patterns complex enough to contemplate the universe that created it. The same logical principles that exclude tachyons have enabled the emergence of minds capable of understanding why tachyons must be excluded. This recursive beauty reveals something almost mystical about the nature of existence. The universe doesn't just contain conscious beings. It seems to have organized itself in such a way that conscious beings inevitably emerge to contemplate their own cosmic context. The prohibition against faster-than-light travel helps ensure that this contemplation can occur in a framework where cause and effect maintain their proper relationship. But let's drift even deeper into this mystery, because there's something profoundly moving about how the universe protects itself from its own potential contradictions. Like a wise teacher who sets boundaries not to limit students, but to create the safe space within which learning can flourish, the cosmos establishes limits that enable rather than constrain the growth of complexity and consciousness. The mathematical frameworks that exclude tachyons also predict the existence of countless other phenomena that do respect causality. Virtual particles that pop in and out of existence in the quantum vacuum, gravitational waves that carry information across cosmic distances at precisely the speed of light, black holes that warp space-time so dramatically that time itself slows near their event horizons. Each of these phenomena pushes the boundaries of what seems possible while remaining safely within the bounds of what is actually possible. The universe appears to be endlessly creative within its self-imposed constraints, like a poet working within the structure of a sonnet to create beauty that wouldn't be possible in free verse. Consider how quantum tunneling allows particles to pass through barriers that should be impenetrable according to classical physics. Or how quantum entanglement creates correlations that Einstein called spooky action at a distance. These phenomena seem to violate our everyday understanding of how the world works, yet they never violate the deeper logical structure that prevents causality violation. It's as if the universe delights in being strange, but only in ways that preserve the underlying coherence that makes strangeness meaningful. Tachyons would represent a kind of strangeness that destroys meaning itself, a weirdness so complete that it would prevent us from recognizing weirdness at all. The absence of these impossible particles thus preserves our capacity for wonder. By ensuring that the universe remains logically consistent, the prohibition against faster-than-light travel creates the intellectual framework within which we can appreciate the genuine mysteries that do exist. Consciousness can emerge to marvel at quantum mechanics precisely because quantum mechanics doesn't permit consciousness destroying paradoxes. This protection of wonder extends to the practical realm as well. The technologies that seem most magical to us, from quantum computers to gravitational wave detectors to the GPS system in your phone, all work by exploiting the strange but consistent properties of a universe that respects its own logical boundaries. These technologies don't violate physical law. They dance with physical law, finding elegant ways to work within cosmic constraints to achieve results that would have seemed impossible to previous generations. The prohibition against tachyons doesn't limit technological progress. It ensures that technological progress occurs within a framework where progress has meaning. As your mind processes these connections, you're experiencing the fruits of this cosmic wisdom firsthand. Your neurons fire in precise sequences, building thoughts from simpler components, creating understanding through the careful accumulation of information over time. This process is possible only because information in your brain respects the same speed limits that govern cosmic communication. The electrical signals that carry your thoughts travel far slower than light, giving your brain time to process and integrate information before new signals arrive. If tachyonic processes were possible in neural networks, the careful temporal orchestration that enables consciousness would collapse into chaos. Thoughts would arrive before the synapses that generate them had fired. Memory would be contaminated by echoes from the future. The impossibility of faster-than-light neural communication is thus intimately connected to the possibility of coherent thought. Your ability to understand why tachyons cannot exist depends on the same constraints that ensure tachyons cannot disrupt your understanding. The mind that contemplates cosmic speed limits is itself shaped by those limits. This brings us to one of the most profound insights that tachyons have offered. The universe isn't just a stage on which consciousness happens to perform. It's a cosmos whose very structure makes the performance of consciousness possible. The laws of physics aren't external constraints imposed on mind. They're the enabling conditions that allow mind to emerge from matter. The prohibition against causality violation doesn't conflict with the emergence of consciousness. It ensures that consciousness can emerge in a form capable of understanding its own cosmic context. The universe that forbids tachyons is the same universe that permits the thoughts you're thinking right now about why tachyons are forbidden. In the gentle darkness of this moment, as these ideas settle into your awareness like snowflakes on a quiet landscape, let yourself appreciate the profound gift of existing in such a carefully balanced cosmos. You inhabit a universe that is creative enough to generate endless surprises, but stable enough that surprises remain meaningful. The tachyons that cannot exist have taught us that impossibility and possibility are not opposites, but partners in an intricate dance. The things that cannot be create the space within which the things that can be achieve their full flowering. The boundaries of the possible are not walls but gardens, carefully tended spaces where complexity and consciousness can grow. Your journey through this exploration tonight has itself been a demonstration of this principle. By following the mathematical paths that lead to impossibility, you've discovered truths about the nature of possibility. By contemplating particles that break time, you've gained deeper appreciation for the time that flows unbroken around you. The equations that describe these impossible travelers will continue to guide physicists toward new understanding. Not because tachyons might someday be discovered, but because their mathematical properties continue to illuminate the structure of the reality that excludes them. They serve as eternal teachers, forever pointing us toward the stable configurations where truth can be found. And in laboratories around the world, scientists will continue to test the boundaries of what's possible, always guided by the understanding that certain boundaries cannot be crossed. They'll push the limits of quantum entanglement while respecting the prohibition against faster-than-light communication. They'll explore the extreme physics of black holes, while acknowledging that some event horizons cannot be crossed and returned from. Each experiment, each discovery, each new technology emerges from this delicate dance between possibility and impossibility. The cosmic speed limit that prevents tachyons also determines the fundamental challenges and opportunities that define the human future. Our species will spread to the stars, if we do, at speeds that respect relativity. We'll communicate across cosmic distances, if we do, through signals that respect causality. These constraints don't limit our cosmic destiny, they define it. By understanding what cannot be achieved, we focus our efforts on what can be achieved. The impossibility of faster-than-light travel becomes a design principle for interstellar civilization. The prohibition against causality violation becomes a foundation for technologies we can barely imagine. But perhaps most importantly, these impossible particles have taught us something about the nature of understanding itself. Knowledge grows not just by discovering what exists, but by carefully reasoning about what cannot exist. The boundaries of the possible are as important as the territories within those boundaries. In contemplating tachyons, you've participated in one of the most beautiful forms of human inquiry. You've used the power of mathematical reasoning to explore realms that no experiment can reach. You've followed logical arguments to conclusions that illuminate the structure of reality itself. You've engaged in the kind of pure thought that reveals the deep kinship between mind and cosmos. The thoughts you've thought tonight about impossible particles are themselves possible only because impossible particles cannot disrupt the logical framework within which thoughts unfold. Your capacity to understand why certain things cannot exist is a manifestation of the cosmic intelligence that ensures they cannot exist. As you prepare to let these ideas dissolve into the gentle rhythms of rest, carry with you this sense of cosmic harmony. The universe you inhabit is not arbitrary or chaotic, but elegantly structured to support the emergence of understanding. The same principles that govern the motion of galaxies govern the formation of your thoughts. The same logic that excludes impossible particles enables the possible consciousness that can contemplate their exclusion. Tomorrow, when you wake to a world where time flows forward and cause precedes effect, perhaps you'll remember these mathematical ghosts that helped illuminate the logical architecture of reality. The tachyons that cannot exist, but in their impossibility, make everything else possible. The particles that break time, but only in equations that time makes possible to write. And in that remembering, you'll carry forward a deeper appreciation for the profound gift of existing in a universe that makes sense. A cosmos where consciousness can emerge to contemplate its own existence, where impossible things can be imagined even as they're excluded from reality, where the boundaries of the possible create the very space within which wonder can flourish. The journey continues tomorrow, as it always does, one moment flowing naturally into the next, building understanding through the patient accumulation of experience over time. The cosmic speed limit that prevents tachyons ensures that this journey can continue, that consciousness can grow, that the universe can come to know itself through minds like yours that emerge within its carefully structured embrace. Sleep well tonight, knowing that you rest within a cosmos that protects the very possibility of rest itself. Dream gently of impossible particles racing backwards through mathematical time, forever teaching us about the real time in which we actually live. And wake tomorrow to a universe where cause precedes effect, where time flows forward, where consciousness can build understanding moment by precious moment in the endless adventure of existence. The tachyons dancing through our mathematical imagination tonight exist in a realm where the impossible becomes illuminating. But there's something even more mysterious about their story. something that touches the very heart of how we understand the relationship between theory and reality. You see, in the strange world of quantum field theory, where particles emerge from invisible fields that fill all of space, tachyons have taught us something profound about the nature of vacuum itself. The empty space around you, the apparent nothingness between atoms, isn't actually empty at all. It seethes with quantum activity, virtual particles popping in and out of existence too quickly to observe directly. This quantum vacuum is remarkably stable in our universe. It maintains a consistent energy level, a baseline from which all other phenomena emerge. But the mathematics suggests that other configurations might be possible, other vacuum states with different properties. And in some of these hypothetical configurations, tachyonic fields might naturally arise. Picture a ball sitting in a valley. It's stable there, content to remain at rest in the lowest point it can find. But imagine that this valley is actually just a local depression in a much larger landscape. Somewhere else there might be an even deeper valley, a more stable configuration that the ball hasn't discovered yet. Our universe's vacuum might be like that ball, stable for now, but perhaps not in the deepest possible state. And if there were a transition to a more stable vacuum, tachyonic fields might appear briefly during that transition, like warning signals that reality is about to reorganize itself completely. This possibility has profound implications for our understanding of cosmic evolution. The universe we inhabit might not represent the final word in cosmic architecture. It might be one configuration among many, stable enough to support complexity and consciousness for billions of years, but not necessarily eternal. The tachyons that cannot exist in our current reality might point toward other realities, other configurations of the cosmic order where different rules apply. Not because the fundamental logic changes, but because the particular way that logic expresses itself might take different forms. Think of it like music. The same mathematical relationships that create harmony in one key can create entirely different melodies in another key. The underlying structure remains consistent, but the surface expression transforms completely. Our universe might be one such melody in the vast symphony of possible realities. But let's drift back to the profound comfort that emerges from understanding these impossibilities. Because even as we contemplate other possible universes, we're grounded in the deep appreciation for the particular universe we actually inhabit. The tachyons that cannot exist here have taught us to value the exquisite balance that makes existence here possible. Consider the delicate choreography required for consciousness to emerge from matter. Atoms must be stable enough to form complex molecules. Molecules must be stable enough to encode information. Information must flow at just the right speed to allow for coherent thought processes. Too fast, and thoughts would blur into chaos. Too slow, and consciousness would never achieve the integration necessary for awareness. The cosmic speed limit that prevents tachyons plays a crucial role in this choreography. It ensures that information processing occurs at scales that allow for the kind of temporal integration consciousness requires. Your brain can form coherent thoughts precisely because neural signals respect the same relativistic constraints that govern cosmic communication. This connection between cosmic physics and consciousness runs deeper than most people realize. The same mathematical principles that exclude faster-than-light particles also determine how memories form, how attention focuses, how understanding grows moment by moment in the quiet theater of awareness. Tonight, as your own consciousness processes these ideas, you're experiencing the fruits of cosmic fine-tuning in its most intimate form. Every neuron firing in your brain, every electrical signal carrying information between cells, every moment of recognition and understanding, all of it unfolds within the temporal framework that makes tachyons impossible. The thoughts forming in your mind right now about impossible particles are themselves possible only because impossible particles cannot disrupt the careful timing that makes thoughts possible. It's a beautiful recursion, consciousness contemplating the cosmic constraints that enable consciousness itself. But there's something even more poetic about how this all fits together. The universe didn't just accidentally stumble into a configuration that permits consciousness. The mathematical relationships that govern reality seem almost designed to support the emergence of minds capable of understanding those very relationships. Consider the remarkable fact that mathematics, developed by human minds working with concepts derived from everyday experience, turns out to describe the behavior of phenomena far beyond everyday experience. The equations that predict the impossibility of tachyons also predict the existence of black holes, the expansion of the universe, the behavior of subatomic particles. This unreasonable effectiveness of mathematics suggests something profound about the relationship between mind and cosmos. Perhaps consciousness isn't an accidental byproduct of cosmic evolution, but an inevitable consequence of the universe's deep mathematical structure. Perhaps minds emerge because the cosmos is, in some sense, already mindful. The tachyons that cannot exist point toward this deeper mystery. They represent the universe's capacity to explore its own logical boundaries through the medium of mathematical thought. When we contemplate these impossible particles, we're participating in the cosmos's ongoing act of self-discovery. This perspective transforms our understanding of what it means to study physics. We're not passive observers examining an external reality. We're expressions of the universe's own curiosity about itself. The questions we ask about tachyons are questions the cosmos is asking about its own structure through us. The equations we write, the thought experiments we conduct, the paradoxes we explore, all of these activities are forms of cosmic self-reflection. The universe is using minds like yours to understand why certain configurations are possible, while others remain forever out of reach. In the gentle quiet of this moment, as your breath deepens and your thoughts begin to settle, let yourself feel the profound intimacy of this cosmic relationship. You are not separate from the physics you're contemplating. You are physics contemplating itself. Your wonder at the impossibility of faster-than-light communication is the universe wondering at its own logical architecture. The tachyons racing backwards through mathematical time exist only in the realm of pure thought. But that realm of pure thought exists only because the universe has evolved to a point where matter can organize itself into patterns complex enough to think about tachyons. The impossible particles serve the possible minds that contemplate them. This brings us to one of the most beautiful insights that emerge from our journey tonight. The boundaries between possible and impossible aren't arbitrary lines drawn by mathematical convention. They're expressions of a deeper cosmic wisdom, a fundamental intelligence that ensures reality remains coherent and meaningful. The prohibition against causality violation isn't a limitation imposed on consciousness from outside. It's the enabling condition that makes consciousness possible in the first place. Without the forward flow of time, without the reliable sequence of cause and effect, minds like yours couldn't emerge from matter at all. The cosmic speed limit that prevents tachyons also protects the temporal framework within which learning occurs, within which memory accumulates, within which understanding grows. Every insight you've gained tonight about the nature of impossible particles has been possible only because impossible particles cannot disrupt the logical structure that makes insight possible. Think of it as a cosmic gift. The universe has organized itself in such a way that conscious beings can emerge to appreciate the very organization that made their emergence possible. The same principles that govern the motion of galaxies also govern the formation of thoughts about galaxies. The same logic that excludes tachyons enables the consciousness that can understand why tachyons must be excluded. But let's explore something even more mysterious about how this cosmic gift expresses itself in the realm of human creativity and discovery. The mathematical frameworks that describe tachyons have inspired some of the most beautiful theoretical developments in modern physics, even though tachyons themselves cannot exist. It's like negative space in a sculpture, where the absence of material creates the shape that gives meaning to the material that remains. The mathematical description of impossible particles has carved out conceptual space that allows us to better understand the particles that actually exist. This principle extends far beyond particle physics. In mathematics, the exploration of impossible objects often leads to the discovery of possible theorems. In art, the constraints of the medium often inspire the most creative solutions. In music, the limitations of harmony create the framework within which melody can flourish. The universe seems to operate on this same principle at the deepest level. The constraints that make certain things impossible create the creative space within which other things become not just possible, but inevitable. The prohibition against faster-than-light travel doesn't limit cosmic creativity. It channels that creativity into the stable patterns that can persist across billions of years of evolution. Consider how this applies to the emergence of life itself. The same physical laws that prevent tachyons also determine how stars form, how heavy elements are created in stellar cores, how planets can maintain stable orbits around their parent stars. The cosmic speed limit is woven into the same mathematical fabric that makes biological evolution possible. Without the temporal asymmetry that tachyons would violate, there could be no clear distinction between past and future. Without that distinction, there could be no evolution, no learning, no growth from simple to complex. The arrow of time that prevents causality violation also enables the emergence of complexity that makes causality meaningful. Life emerges within this temporal framework, building on the reliable sequence of molecular interactions that respect relativistic constraints. DNA replication depends on chemical processes that unfold in proper temporal order. Neural development requires signals that propagate at subluminal speeds. Consciousness itself depends on the integration of information over timescales that respect the cosmic speed limit. You are not just a beneficiary of this cosmic architecture. You are an expression of it. Every cell in your body, every thought in your mind, every moment of awareness you experience represents the universe exploring its own creative potential within the boundaries that ensure coherence and meaning. The tachyons that cannot exist have taught us something profound about the nature of existence itself. Reality is not a random collection of phenomena held together by arbitrary rules. It's a carefully orchestrated symphony where every constraint enables new forms of creativity, where every impossibility creates space for new possibilities. Tonight, as you drift toward rest, let this understanding settle into your bones. You inhabit a universe that is strange enough to inspire infinite wonder, but stable enough that wonder can accumulate into wisdom. The cosmic speed limit that prevents faster-than-light travel also ensures that consciousness can travel from ignorance to understanding at exactly the right pace. The mathematical ghosts we've contemplated tonight will continue their eternal journey through the realm of theoretical possibility. They'll keep racing backwards through imaginary time, forever teaching physicists about the structure of real time. They'll keep appearing in equations as signals that guide theory toward truth. But you, resting now in the gentle darkness, exist in real time. The time that flows forward, carrying you from one moment of understanding to the next. The time that allows memories to form and dreams to unfold. The time that makes stories possible, including the story of consciousness discovering its own cosmic context. In the morning, when you wake to a universe where cause precedes effect and information flows at finite speed, perhaps you'll carry with you a deeper appreciation for these simple gifts. the gift of temporal order that makes learning possible, the gift of causal structure that makes choices meaningful, the gift of a cosmic speed limit that protects the very possibility of meaning itself. The tachyons that break time exist only in the mathematical imagination that time makes possible. The particles that violate causality live only in minds that causality makes possible to form. The impossible and the possible dance together in the eternal choreography of cosmic self-discovery. And you, dreamer and thinker, are both audience and performer in this cosmic dance. Your capacity to contemplate impossibility is itself a manifestation of the possible. Your wonder at particles that cannot exist is the universe wondering at its own logical beauty. Your understanding grows in the gentle flow of time that those impossible particles would destroy. Sleep now in the knowledge that you rest within a cosmos that protects the very conditions that make rest meaningful. Dream of mathematical travelers racing through theoretical space-time, forever showing us the boundaries that make our own journey through real space-time possible. And wake tomorrow to continue the endless adventure of consciousness, exploring the reality that made consciousness possible in the first place. The story continues, as all good stories do, one moment flowing naturally into the next, building meaning through the patient accumulation of understanding over time. The cosmic speed limit ensures that this story can continue, that consciousness can grow, that the universe can come to know itself through minds like yours, that flower within its carefully structured embrace. The profound paradox of tachyons reveals something even more beautiful about the nature of scientific discovery itself. These impossible particles have become some of our most valuable teachers, not in spite of their impossibility, but because of it. They stand as eternal sentinels at the boundaries of what can be, forever pointing us toward the deeper truths that emerge from understanding what cannot be. In the laboratories and universities where physicists work today, tachyons serve a role that might seem surprising. They appear regularly in theoretical calculations, not as entities to be discovered, but as warning signals. When a physicist derives equations that predict tachyonic behavior, they know immediately that something profound is happening in their mathematics. The theory is telling them that they've stumbled across an unstable configuration, a mathematical house of cards that must collapse into something more fundamental. This process of collapse, known as tachyon condensation, has become one of the most elegant tools in modern theoretical physics. It's like watching a river find its course down a mountainside. The water doesn't fight against the landscape. It flows naturally toward the most stable configuration, carving channels that become more durable with each passing season. Think of the early universe, in those first moments after the Big Bang, when reality itself was still finding its form. The cosmos might have existed in a state of perfect symmetry, mathematically beautiful but fundamentally unstable. Tachyonic fields in such a configuration would signal that this pristine symmetry could not last. The universe would need to break its own perfection, settling into the less symmetric but more stable reality we observe today. In this view, the impossibility of tachyons in our current universe might be intimately connected to how our universe achieved its current form. The particles that cannot exist here might have played a crucial role in guiding reality toward a configuration where they themselves became impossible. It's a beautiful self-correcting process, like a poem that writes itself into existence by eliminating the words that don't belong. But let's drift deeper into something even more mysterious about these theoretical travelers. The mathematics that describes them has revealed unexpected connections between seemingly unrelated phenomena. The same equations that predict the impossibility of faster-than-light particles also illuminate the behavior of phase transitions in condensed matter physics, the dynamics of inflation in cosmology, the stability of vacuum states in quantum field theory. It's as if tachyons represent a kind of mathematical DNA, a fundamental pattern that expresses itself across multiple domains of physics. Their impossible properties serve as a template that helps us understand real phenomena in contexts far removed from particle physics. The mathematics of impossibility becomes a tool for exploring possibility. Consider how this principle operates in string theory, the ambitious attempt to unify all the forces of nature into a single mathematical framework. In string theory, tachyonic fields appear naturally in certain configurations of the extra dimensions that the theory requires. But rather than representing faster-than-light particles, these tachyonic modes signal that the configuration is unstable and must evolve towards something more fundamental. The process is remarkably elegant. The presence of tachyons guides the theory away from unstable configurations and toward the stable vacuum states where ordinary matter and energy can exist. It's like having a cosmic compass that always points toward consistency, toward the mathematical structures that can actually support the emergence of complexity and consciousness. This guiding principle has led to some of the most profound insights in modern physics. String theorists have learned to read the presence of tachyons, like ancient mariners read the stars, using these impossible particles to navigate toward the stable configurations that might describe our actual universe. But there's something even more beautiful about how this navigation works. The mathematics doesn't just exclude tachyons randomly. It does so in a way that preserves the most interesting and complex possibilities. The stable configurations that emerge from tachyon condensation are often richer and more intricate than the symmetric states they replace. It's like watching a master sculptor work with marble. Each strike of the chisel removes material that doesn't belong, revealing the beautiful form that was always hidden within the stone. Tachyonic instabilities serve as the universe's chisel, carving away the configurations that cannot persist and revealing the stable structures that can support billions of years of cosmic evolution. Tonight, as you rest in this understanding, let yourself marvel at the profound intelligence embedded in the mathematical structure of reality. The universe doesn't just accidentally avoid contradictions. It actively seeks out the most elegant and sustainable configurations, guided by principles that ensure coherence and meaning can emerge from cosmic chaos. The tachyons that cannot exist are part of this deeper intelligence. They serve as mathematical guardians, protecting the logical consistency that makes everything else possible. Their very impossibility creates the space within which possibility can flourish in its most beautiful forms. Consider how this applies to the phenomenon of quantum entanglement, one of the strangest aspects of quantum mechanics. When two particles become entangled, their properties become correlated in ways that seem to transcend space and time. Measure one particle, and you instantly know something about its partner, no matter how far away it might be. This quantum correlation appears to violate our everyday understanding of locality. How can one particle instantly affect another across vast distances? The answer lies in understanding that while entanglement creates correlations that seem to transcend space, it cannot be used to send information faster than light. The cosmic speed limit remains intact even in the weird world of quantum mechanics. The prohibition against tachyons ensures that quantum entanglement remains mysterious, but not paradoxical. The correlations between entangled particles are real, but they cannot be exploited to violate causality. It's as if the universe allows strangeness, but only within carefully defined limits that preserve the logical structure of reality. This principle extends to every domain of physics. Black holes can warp spacetime so dramatically that time itself slows to a crawl near their event horizons. But even black holes cannot create closed loops in time that would allow information to travel into the past. Gravitational waves can ripple across the cosmos at the speed of light, carrying information about the most violent events in the universe, but they cannot outrun light itself. Each phenomenon pushes the boundaries of what seems possible, while respecting the deeper constraints that keep reality coherent. The universe appears to delight in being strange, but only in ways that preserve its fundamental logical integrity. Tachyons would represent a kind of strangeness that destroys logic itself, a weirdness so complete that it would prevent us from recognizing any other kind of weirdness. The absence of these impossible particles thus preserves our capacity for wonder. By ensuring that the universe remains logically consistent, the prohibition against faster-than-light travel creates the intellectual framework within which we can appreciate the genuine mysteries that do exist. Consciousness can emerge to marvel at quantum mechanics precisely because quantum mechanics doesn't permit consciousness-destroying paradoxes. As your mind processes these connections tonight, you're experiencing this cosmic wisdom in its most intimate form. Your thoughts unfold in sequence, building understanding moment by moment. Your memories preserve the past without being contaminated by echoes from the future. Your capacity for reason depends on the same logical structure that excludes impossible particles. The neurons firing in your brain right now operate according to the same relativistic principles that govern the motion of spacecraft. The electrical signals carrying your thoughts respect the same speed limits that constrain cosmic communication. Even the biochemical processes sustaining your life unfold within the temporal framework that makes tachyons impossible. You are not separate from the physics you're contemplating. You are physics contemplating itself. Your capacity to understand why certain particles cannot exist is itself a manifestation of the cosmic intelligence that ensures they cannot exist. Your wonder at these impossibilities is the universe wondering at its own logical architecture. But perhaps the most profound lesson that tachyons teach us concerns the nature of time itself. We experience time as flowing from past to future in a steady, inexorable stream. This temporal flow seems so natural that we rarely question why it should be this way at all. Yet the fundamental equations of physics are largely symmetric with respect to time. Most physical processes could, in principle, run backwards just as easily as forwards. The prohibition against tachyons offers crucial insight into this deep mystery. By preventing information from traveling backwards through time, the cosmic speed limit helps maintain the very asymmetry that gives time its direction. Without this prohibition, the careful distinction between past and future would dissolve into paradox. Imagine consciousness trying to function in a universe where tachyons existed. Information from the future would constantly leak into the past. Effects would precede their causes in an endless web of circular causation. The clean arrow of time that allows for memory, learning, and growth would become tangled beyond recognition. In such a universe, the very concept of choice would become meaningless. How can you make a decision when the consequences of that decision reach backwards to influence the conditions that led to the choice? How can you learn from experience when future experiences contaminate present understanding? The absence of tachyons protects something even more fundamental than causality. It protects the possibility of meaning itself. Without the forward flow of time, without the reliable sequence of cause and effect, stories cannot unfold, purposes cannot be pursued, consciousness cannot build the integrated understanding that makes awareness possible. This protection operates at every level of your existence. Your ability to form memories depends on neural processes that respect the cosmic speed limit. Your capacity for learning relies on information processing that unfolds in proper temporal sequence. Even your sense of personal identity emerges from the continuity of experience that tachyons would shatter. The impossible particles we've contemplated tonight exist only in mathematical imagination, but that imagination exists because the universe has evolved to support minds capable of imagining the impossible while remaining grounded in the possible. The thoughts you're thinking about tachyons are possible only because tachyons cannot disrupt the logical framework that makes thoughts possible. In the gentle darkness surrounding you now, feel the profound gift of inhabiting a universe that protects its own coherence. The cosmic speed limit that prevents faster-than-light travel also ensures that consciousness can emerge to contemplate that very limit. The prohibition against causality violation creates the temporal framework within which violating causality can be imagined but never achieved. This recursive beauty reveals something almost sacred about the nature of cosmic order. The universe doesn't just contain conscious beings. It has organized itself in such a way that conscious beings inevitably emerge to appreciate the very organization that made their emergence possible. The same principles that govern the motion of galaxies also govern the formation of thoughts about galaxies. Tomorrow morning, when you wake to a world where time flows forward and cause precedes effect, perhaps you'll carry with you a deeper appreciation for these simple gifts. The gift of temporal order that makes planning possible. The gift of causal structure that makes ethics meaningful. The gift of a cosmic speed limit that protects the very possibility of meaning itself. The tachyons that break time will continue their eternal journey through the realm of mathematical possibility, forever racing backwards through imaginary moments, forever teaching us about the real moments in which we actually live. They serve as companions in the great adventure of understanding, guides that point us always toward truth by showing us the territories where truth cannot be found. And in that guidance, we discover something beautiful about the relationship between knowledge and mystery. The more we understand about why certain things cannot exist, the more we appreciate the exquisite balance that allows other things to exist. The boundaries of the possible are not walls, but gardens, carefully tended spaces where complexity and consciousness can flourish. Sleep now in the knowledge that you rest within a cosmos that knows its own limits, and in knowing them, transcends them. The particles that cannot exist make everything else possible. The speed that cannot be exceeded creates the temporal framework within which all other speeds find their meaning. The impossibility we've explored tonight illuminates the precious possibility of the life you're living right now. But there's one final mystery that tachyons whisper to us across the mathematical void. Something that touches the very heart of what it means to exist in a universe that can dream of its own impossibilities. As you lie here tonight, breathing softly in the darkness, consider this profound truth. The tachyons that cannot exist have taught us more about the nature of existence than many particles that actually do exist. This is the beautiful paradox of theoretical physics. Sometimes the most illuminating discoveries come not from finding what we're looking for, but from understanding with perfect clarity why we cannot find it. The absence becomes as meaningful as presence. The forbidden becomes as instructive as the permitted. Think of how this principle operates in your own life. The paths you cannot take often define the meaning of the paths you do take. The words you choose not to speak give weight to the words you do speak. The dreams that remain impossible create the space where achievable dreams find their purpose. Tachyons exist in this same liminal space between the imaginable and the achievable. In laboratories around the world tonight, while you rest, equations are being written that contain these impossible particles, not because scientists expect to find them, but because their mathematical presence serves as a kind of cosmic proofreader, checking the consistency of our theories against the deeper logic of reality itself. When tachyons appear in a calculation, they're like red ink in the margins of the universe's textbook, marking where the theory has wandered into forbidden territory. This process of mathematical correction has guided some of the most beautiful discoveries in modern physics. The equations that describe the Higgs field, the invisible ocean of energy that gives particles their mass, originally contained tachyonic solutions. But through the process we've explored tonight, these unstable configurations collapsed into the stable field that now fills all of space, giving mass to electrons, to protons, to the very atoms that compose your body. The tachyons that couldn't exist paved the way for the mass that does exist. The particles that would have broken causality helped create the causal structure within which you can think about causality. It's as if the universe used impossible particles as scaffolding while constructing the possible reality you inhabit, then removed the scaffolding once the construction was complete. But perhaps the most beautiful aspect of this cosmic architecture is how it preserves both mystery and meaning. The universe could have been utterly transparent, with no puzzles left to solve, no questions left to ask. Or it could have been utterly opaque, beyond the reach of any understanding. Instead, it chose a middle path, strange enough to inspire endless wonder, but coherent enough that wonder can ripen into wisdom. The prohibition against tachyons is part of this delicate balance. By preventing the most extreme forms of paradox, it creates space for the gentler mysteries that enrich rather than destroy our understanding. Quantum mechanics can be weird because it's not weird enough to break logic entirely. Black holes can warp space-time dramatically because they don't warp it enough to create closed loops in time. Each phenomenon in physics pushes against the boundaries of comprehension while respecting the deeper boundaries that make comprehension possible. It's like a jazz musician improvising within the structure of a song. The creativity emerges from the constraints, not in spite of them. The universe improvises endless variations on the theme of existence while never abandoning the harmonic structure that makes the music meaningful. Tonight, as your consciousness drifts between waking and sleeping, you're experiencing this cosmic improvisation in its most intimate form. Your dreams will unfold according to their own strange logic, but even the strangest dreams respect the temporal framework that tachyons would violate. In sleep, you may fly or speak with the dead or visit impossible places, but you'll do so in a sequence of dream moments that flow from earlier to later, never backwards through time. The impossibility of tachyons protects even the realm of dreams. Your sleeping mind can imagine traveling faster than light, but it cannot actually experience the causality violations that such travel would entail. The universe maintains its logical integrity even in the landscape of the unconscious, even in the territory where imagination roams most freely. This protection extends to every form of human creativity. When storytellers craft tales of time travel, they work within narrative constraints that echo the cosmic constraints on actual time travel. Stories need beginnings, middles, and ends. Characters need to experience consequences that follow from choices. Even the most fantastical narratives depend on the causal structure that tachyons would destroy. The myths and legends that have guided human understanding for millennia all unfold within the temporal framework that makes tachyons impossible. The hero's journey from innocence to wisdom, from ignorance to understanding, from weakness to strength. These transformations require time to flow forward, experience to accumulate cause and effect, to maintain their proper relationship. In this sense, the impossibility of faster-than-light particles protects not just the possibility of science, but the possibility of story itself. Without the arrow of time, there could be no narratives, no character development, no meaning that emerges from the sequence of events. The cosmic speed limit preserves the very foundation upon which all human meaning-making depends. And so, as you drift into sleep tonight, let yourself feel grateful for these invisible constraints that make visible meaning possible. The tachyons that cannot exist have created the space where stories can exist, where consciousness can emerge to tell those stories, where the universe can come to know itself through the narratives that minds like yours weave from the fabric of experience. The mathematical ghosts we've contemplated together will continue their eternal dance through theoretical spacetime, forever racing backwards through equations that time makes possible to write. They'll keep appearing in the calculations of physicists yet unborn, serving as eternal teachers, forever pointing toward the stable configurations where truth can flourish. But you, dreamer and thinker, rest now in real time. The time that flows gently forward, carrying you from one moment of understanding to the next. The time that allows memories to form and dreams to unfold. The time that makes possible the very story of consciousness discovering its own cosmic context. In the morning, when you wake to a universe where causes precede effects and information travels at finite speeds, perhaps you'll carry with you a deeper appreciation for the profound gift of temporal order. The gift of a cosmos that protects the conditions necessary for meaning itself. The gift of impossible particles that make everything else possible. The Slumber Lab thanks you for joining this gentle exploration tonight. Until we meet again in the quiet spaces where wonder blooms, sleep well in the knowledge that you inhabit a universe wise enough to dream of its own impossibilities, while remaining grounded in the beautiful logic that makes dreams themselves possible. The tachyons that break time exist only in the mathematical imagination that time makes possible. And that imagination exists because you exist, consciousness flowering in the garden of constraints that make consciousness possible. Sweet dreams, fellow traveller in this impossible possible universe.